Hi, this is Jani from jDrones. The next video is one of our conference videos that we have been recording in our ArduPilot developer conference during June 2019 at Drone World Congress in Shenzhen. I will be talking about how to build your custom-made firmware for ArduPilot and custom-made hardware. I hope you enjoy the conference videos. All right, at least now it's working. So yeah, Chibios systems and hardware. Where's the? Do I have battery left in here? All right. So some of you probably know that we are currently using a WAF build system, which is being written mostly in Python. It's a really powerful building system for all kind of software projects, and it allows us to modify code and configurations really easily. It runs on all Windowses, it runs on Linuxes, Macintoshes and others, basically natively. On Windows we run it under the Cygwin. On Linux it's a native, and same thing because on Mac, because Mac is basically a Linux. So the most important repositories that are involved on whole software development is, first of all, GitHub, the ArduPilot/ArduPilot. That's where the main software is. All the flight code for rovers, boats, submarines, whatever, is on that one. Then the other one is the bootloader, that if you are developing your own hardware, you need to have your own bootloader to make sure that all the hardware configurations are correct. So those two ones you need to have on your computer when you start working hardware. Then some other important files, when we starting to making the configuration files for your absolutely beautiful autopilot. You wouldn't believe, but this is actually a working autopilot. Is in ArduPilot libraries ap_hal_chibios. And then we have the hardware definition file, and that's your folder where you have to put your own. So if you have whatever folder, let's say, in my case, this is JD F405 Mini. So this would be JD F405 Mini folder, and there we have the final hardware definition file that tells for the build system that what all things we have on this board. Then on the bootloader, what I was talking earlier, we have basically one single file that we need to be care. It's the board_types. I come to that one a little bit later. And of course, yeah, when you're building your hardware, you're building your software, they are going to be under ArduPilot build and then a board name. There's going to be bootloaders, there's going to be the real firmwares and everything like that one. So when you're running WAF build system, everything happens inside the main ArduPilot folder. Commands are, well, we tried to make it as easy as possible. Commands are really simple, straightforward. WAF, configure, board, what is my board name? And then if I want to build the bootloader, I just add the -- bootloader. After that, I say that, okay, WAF, bootloader, build me the bootloader. And if all your configuration files are correct, in a matter of minutes, you will have a bootloader that works on your board. Then when you are creating the final firmware, is it a copter or a plane or whatever, same again, you have WAF, configure, board, and then your board name. The last one is that, okay, which one device I want to build. WAF, copter in this case. So it's pretty straightforward. There are many other commands and many other options what you can put, but mostly when you're working on a hardware that you have on your desk and you want to test that, okay, do we have correct connections and others, it's basically only these two commands what you are using. Every time when you make the configuration changes, if you have mistakes, but we all know no one is making mistakes, right? So you just say always that, okay, configure it again and build it again. And then you can upload it again to your hardware. So there are three main sections on the hardware definition file. MCU definitions, okay, what kind of a microcontroller you have on board. Is it going to be 405 based or any kind of 4XX based, or is it going to be 7 based? So you need to put all those ones. Then, of course, one of the most important one is the GPIOs, because the build system need to know where everything is on the board. Then, let's say, a little bit less important, especially on first run, is the board configuration, just like which way my sensors are facing on that one. If you have a mistake on that one, well, yeah, your IMU might be working upside down or something like that one, but at least it's working. So those are the three main sections that you have to look on the file. There's a small, I think actually this is for this one board. That's the MCU configurations. I'm using 405 on my demo board, which is a Waveshare, just normal off-the-shelf demo board. Earlier I was talking about that bootloader and the board type. So this is the number that has to match in that the board type file on the bootloader folder. So if you have a mismatch in here, your system won't work. And basically, all people, all different hardware should have their own board ID. If you have two exactly similar, let's say the physical size is different, then it doesn't matter. But if you have two boards, for example, both of them are running with a 405, but you have different sensors, different sensor companies and others, in that case you should have also a different board ID. Then another thing related to MCU, of course, your clock speeds and that kind of basic stuff. Voltage levels and so on. Then on GPIO, pretty basic, simple. Where's my LEDs? Where's my I2C buses if I have them? What is the order of I2C buses? If we have multiple I2C buses, we can say, okay, I2C number 1 are connected on PB8, PB9. I2C number 2 might be, for example, PP10, PP11. And then we just say that, okay, what is the order? That first we have a I2C1, I2C2, 3, 4, and so forth. All these pins has to match an additional file, which is also in the hardware definition folder, because we have a special file that defines that what different pins can do for every single MCU. So someday if you have a problem that you cannot compile your system, then you need to check that, am I trying to use some pin for I2C which is not even defined to be having an I2C. SPI, yeah, it looks this board. So PA5, PA6, PA7 is the SPI normal, SPI pins. Then, even though these are related to SPI, it's not that important because they are just normal GPIO. SPI is special pin in microcontrollers. But like for the chip select and others is not. So we can basically use whatever available IO pin. Same thing on outputs, USBs and others. Follows the same direction. Okay. Then board definitions. Okay, earlier we were defining those LEDs and others. In here it's more like for how they are really connected. Do we have LEDs? What kind of devices we actually have? Just like in this board, okay, I have a MS5611 barrel. I have a, where is it? There is a MPU 9250 on an SPI bus. And then also one important thing is that which is the orientation of that kind of a device. And then what other things, what we want to do? Do we want to have a arming alarm if we don't have the compasses and others? So all that one can be put on the board definition. All right. So on this one board, in here, I have on the red ones we have IMU and barometer connected. On pink or magenta we have the SD card connected, and then on the blue ones we have the LEDs. Yeah. So, all right. And because of we don't have enough time and my computer is not that powerful of compiling it, I was compiling these ones ready for you already. So currently I have this configuration inside, which is that we are using PA4 for the barometer. I know it's wrong. And then we are using a orientation for the IMU. It's a 90 degrees orientation, which is also wrong. So let's just go. Now where's my mission planner? There. Right. We have it on COM17. All right. So immediately we can see that, something is not wrong. We messed up something because we cannot initialize barrels or anything like that one because of the chip selects are incorrect. If I would now start moving the cables, it would actually start working, but I don't want to touch on the cables. So I'm going on the other way. All right, let's disconnect. And now I'm just making this one bigger. So now we had this one inside on the board. So, and we noticed, oops, we had a mistake in here. We had the PA4 made for the chip select for that. So let's put the firmware that we have the PC3 for the chip select, which is correct. Now, let's just upload it, firmwares, load custom firmwares, and we were earlier in a demo 1, so let's go on demo 2, and like I said, we have the build folder in here. Normally this would be a ArduPilot, but I just renamed them to be AP demo 2. So there's my board, JD FO5 Mini, ArduCopter, and there's the bin folder, and there we have the ArduCopter APJ, which is our binary. And let's hope that reading hex file, scanning COM ports, erasing. Now it's erasing the flight controller, well, MCU.
Did you actually change the hard-to-find file and just compile it?
It takes 10 minutes or more to compile. I can do later on. I can just run it quickly through a configuration and others. So still erasing. Okay. Upload done. Let's just wait a while. because I don't have the buzzer, so I don't know when the upload is done, but about now. So if everything goes now well, we should have a fully working, yes, all right. It works, and we are a little bit better than. We don't have any more the barrel error in here, and we can see that, yeah, it works. But did we have some problems still on the system? If I now moving this one forward, that one should actually go higher. Oops, no, it's not going higher. But it should be, because this is now facing forward. So this should be going upwards, right banking, left banking. So what's the wrong in here? Now, what did our configuration show? We are using now this one. The yaw is only 90 degrees because the IMU is 90 degrees turned. Actually, it's not. It's 180 degrees turned. Then it would be okay. So this one configuration line is still wrong. Okay, let's go and try the number 3. In number 3, we have PC3, like it's correct, and we also using now the correct rotation of the IMU. So, like I said, I'm moving nose down, and it goes sideways, which is wrong. Okay, disconnect. Now we compiling the new firmware. Okay, our firmware is compiled. Good. So let's go on AP demo 3, build folders, binary, and upload the new freshly compiled file. Go, go, go. Maybe I need to reset the. Take it now. Okay, let's try again. Let me take the USB out. This is the reason why hardware demos are always difficult, because there can be all kind of small things. I just restart Mission Planner just in case. Normally you would actually do that one directly from the command line, because you don't need to really go on Mission Planner to upload the firmwares, but I don't want to do the compiling now in here. So, okay, AP demo 3, reading file, scanning compose. Okay, now it's erasing. All right, programming. So yeah, there's two ways of doing. You can do it from the Mission Planner, or you can do it directly in here. That when you do the WAF copter, if you want automatic upload, you just do WAF copter -- upload. And after the upload is done, it automatically uploads all the new firmware on the board. So that's one way. Done. So let's see. There we go. All right. Everything looks better. We don't have any more. We don't have that barrel error. And let's just get it the parameters first. Okay, yeah. Now if I take the autopilot and pull the nose down, the artificial horizon and everything looks exactly like it should be. So now all the settings are correct. as we were talking earlier about documentation and others, there's a huge amount of this kind of configurations and others, and we don't have yet a proper list of those ones, but we are hardly working and trying to get those one done in the next few months. So currently the best source of having those one is the FMU v3 in our Git repositories. There's most of the sensors are listed, all the ways how to bind it and others, so that's the best source for now. And there's a lot of these configurations already what people can look and check that what is included in where. So Tom wanted to see, let's see, there. So let me just move it a little bit. Okay, let's make it bigger. There, so WAF. I will clean it first. Clean. No, it's fine. So let's make that configuration config board JD underscore F405 mini. Now the configuration part starts. It won't take usually long. Done. So if you changed your hardware settings or whatever, you just run that configuration once, and after that you say WAF copter, and then it starts to build. This one will take now quite a while, especially on my computer. If you have a powerful computer, Randy is building probably 100 times per day. So depending on your settings and others, if you're using CC cache and others, the build times can be even matter of 20-30 seconds at a time. But yeah, in here it's going to take 7-8 minutes on this laptop. All right. Thank you. And any questions? Seems no. Everyone understands quite perfectly well. Good. All right. Then I would like to invite Mr. Che.
Sorry, Jani, just before we move on, I just wanted to say, sorry, regarding the Chibios hardware definitions and compiling for new hardware, we have a Gitter channel. Do you know Gitter? Gitter is live chat, and so if you open up gitter.im and then go to ArduPilot, Chibios, you will find many developers in there who are developing, for new boards, and they're very helpful. So if you want to make ArduPilot work on a new flight controller, you will find very helpful people in that chat.